Section 1, Matter. Every object in the universe is made of particles of some kind of substance. Scientists use the word matter to describe the substance of which objects are made. Matter is anything that takes up space and has mass. The amount of matter in any object is the mass of the object. All matter has observable and measurable properties. Scientists can observe properties of a substance to identify the kind of matter that makes up the substance. Properties of matter. All matter has two types of distinguishing properties: physical properties and chemical properties. Physical properties are characteristics that can be observed without changing the composition of the substance. For example, physical properties include density, color, hardness, freezing point, boiling point, and the ability to conduct an electric current. Chemical properties are properties that describe how a substance reacts with other substances to produce different substances. For example, a chemical property of iron is that iron reacts with oxygen to form rust. A chemical property of helium is that helium does not react with other substances to form new substances. Understanding the chemical properties of a substance requires knowing some basic information about the particles that make up all substances. An element is a substance that cannot be broken down into simpler, stable substances by chemical means. Each element has a characteristic set of physical and chemical properties that can be used to identify it. Figure 1 shows the most common elements in Earth's continental crust. More than 90 elements occur naturally in Earth. About 24 other elements have been created in laboratories. Of the natural elements, 8 make up more than 98% of the Earth's crust. Every known element is represented by a symbol of 1 or 2 elements. So as you see, oxygen is the most abundant element in the Earth's crust, then silicon, then aluminum, then iron. Atoms. Elements consist of atoms. An atom is the smallest unit of an element that has the chemical properties of that element. Atoms cannot be broken down into smaller particles that will have the same chemical and physical properties as the element. A single atom is so small that its size is difficult to imagine. To get an idea of how small it is, look at the thickness of this page. More than 1 million atoms lined up side by side will be equal to this thickness. Atomic structure. Even though atoms are very tiny, they are made up of smaller particles called subatomic particles. 3 major kinds of subatomic particles are protons, electrons, and neutrons. Protons are subatomic particles that have a positive charge. Electrons are subatomic particles that have a negative charge. Neutrons are subatomic particles that have no charge. The nucleus. As shown in Figure 2, the protons and neutrons of an atom are packed close to one another. Together they form the nucleus, which is a small region in the center of the atom. The nucleus has a positive charge because protons have positive charge and neutrons have no charge. The nucleus makes up most of the atom's mass, but very little of the atom's volume. If an atom's nucleus were the size of a gumdrop, the atom itself would be as big as a football stadium. Because electrons are even smaller than protons and neutrons, the volume of the atom is mostly empty space. The electron cloud. The electrons in an atom move in certain regions of space called an electron cloud that surrounds the nucleus. Because opposite charges attract each other and negatively charged electrons are attracted to the positively charged nucleus, this attraction is what holds electrons in the atom. So this diagram is showing you that the nucleus is in the middle, really small, and the amount of area that is taken up by the electron cloud. And in all reality, this electron cloud would be much bigger. The atomic number. The number of protons in a nucleus of an atom are called the atomic number. The atoms in any given element have the same all atoms of any given element have the same atomic number. An element's atomic number sets the atoms of the element apart from atoms of all other kinds of elements as shown in figure 3. Because an uncharged atom has an equal number of protons and electrons, the atomic number is also equal to the number of electrons in an atom of any given element. Elements on the periodic table are ordered according to their atomic numbers. The periodic table, shown in the following pages, is a system of classifying elements. Elements in the same column on the periodic table have similar arrangements of electrons in their atoms. Elements that have similar arrangements of electrons have similar chemical properties. The atomic mass. The sum of the numbers of protons and neutrons in an atom is the mass number, or atomic mass. The mass of a subatomic particle is too small to be expressed in grams, so a special unit called the atomic mass unit, AMU, is used. Protons and neutrons each have an atomic mass that is close to 1 AMU. In contrast, electrons have much less mass than protons and neutrons. The mass of one proton is equal to the combined mass of 1,840 electrons. Because the electrons add too little to the atomic's mass, their mass is ignored when calculating the atom's approximate mass. Isotopes. Although atoms of given elements contain the same number of protons, the number of neutrons may differ. For example, while most helium atoms have 2 neutrons, some helium atoms only have 1 neutron. An atom of the same number of protons, or the same atomic number, as the atoms of the same element do, but has a different number of neutrons, and thus different atomic mass, is called an isotope. A helium atom has 2 neutrons. A helium atom that has 2 neutrons is more massive than a helium atom that only has 1 neutron. Because of their different number of neutrons and their different masses, different isotopes of the same element have slightly different properties. If we take a look at hydrogen, hydrogen normally has 1 proton, 1 electron, and no neutrons. Sometimes hydrogen will have 1 proton, 1 electron, and 1 neutron, and it'll have an atomic mass of 2. That's called deuterium. And sometimes hydrogen will have 1 proton, 1 electron, and 2 neutrons, and it'll have an atomic mass of 3, and that's called tritium. Average atomic mass. Because the isotopes of an element have different masses, the periodic table uses an average atomic mass for each element. The average atomic mass is the weighted average of the atomic mass of the naturally occurring isotopes of an element. As shown in figure 4, hydrogen has 3 isotopes. Each isotope has different mass because each has a different number of neutrons. By calculating the weighted average of the atomic mass of the 3 naturally occurring hydrogen isotopes, you can determine the average atomic mass. As noted on the periodic table, the average atomic mass of hydrogen is 1.00784 AMUs, and an AMU stands for atomic mass unit. Valence electrons in the periodic table. Based on similarities in their chemical properties, elements on the periodic table are arranged in columns, which are called groups. An atom's chemical properties are largely determined by the number of outermost electrons in an atom's electron cloud. These electrons are called valence electrons. Within each group, atoms of each element generally have the same number of valence electrons. For groups 1 and 2, the number of valence electron each atom has is the same. the same as that atom's group number. Atoms in the elements 3 through 12 have 2 or more valence electrons. Groups 13 through 18, the number of valence electrons in each atom is the same as the atom's group number minus 10, except for helium. Helium only has 2 valence electrons. Atoms in group 18 have 8 valence electrons. When an atom has 8 valence electrons, it is considered stable or chemically unreactive. Unreactive atoms do not easily lose or gain electrons. Elements whose atoms have only 1, 2, or 3 valence electrons tend to lose electrons easily. These elements have metallic properties and are generally classified as metals. Elements whose atoms have from 4 to 7 valence electrons are more likely to gain electrons. Many of these elements, which are in groups 13 through 17, are classified as nonmetals.